Hello, protocols, packets, and programs. Software has so many things that aren't real. I don't mean things that are non-existent, like a general solution to the halting problem or the metaverse. I mean things we describe, like intelligence that's artificial, reality that's virtual, code that's secure. Which means this week we count down a ton of AppSec news with a two's complement of co-hosts. Be authentic and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Ransomware, supply chain attacks, 0 days. Cyber threats don't wait, and neither should your defenses. With ThreatLocker, you're not just reacting to threats, you're stopping them before they start. Our Zero Trust endpoint protection locks down your environment with pinpoint control over what's allowed to run and what's not. No guesswork, no blind spots. Just proactive, built-for-now security that keeps your business moving. Want to see how a true default deny strategy works? Head over to securityweekly.com/threatlocker and take the first step towards shutting the door on threats before they even knock. Generative AI is powerful, but it comes with real risks, from prompt injection to data leakage misuse and agentic AI. The OWASP Gen AI Security Project unites a global community of expert practitioners who tackle these challenges every day. Together, they've built practical playbooks, adoption guides, and the OWASP Top 10 for LLMs, resources any team can apply right now to strengthen AI security. And it doesn't stop there. This is open source, built by practitioners, for practitioners, working together to secure generative AI. Visit securityweekly.com/OWASP to use the playbooks and join the effort to protect tomorrow's intelligence today. This is episode 349, recorded September 22nd, 2025. I'm your host, Mike Shima. I'm here with John Kinsella. Hello, John, and I love the shirt.
Why, thank you. I needed a little bit of color today after I got to go see Banana Ball this weekend, so thought I'd do something different.
We got a lot of Banana Ball color on the video stream this week, so listeners, go become some viewers this week. You got to check it out. You also have to check out, we have Kalyani with us. Hello, Kalyani.
Hello, I'm so happy to be back.
Happy to have you here, and we've got a lot of news articles just waiting for you. So I'm glad you had the time this week. Also want to give a quick shout out and thank you to Adrian Sanabria and Josh Marpet for filling in last week. One quick announcement, join us for InfoSec World 2025, October 27th to 29th in sunny, maybe it'll be sunny, in October, Lake Buena Vista, Florida at Disney's Coronado Springs Resort. Workshops run October 25 to 26 and October 29 to 30. The premier cybersecurity conference is here. What a good rhyme. Save 25% with code ISW25-SW at securityweekly.com/ISW2025. Whew, okay, and I'm already stumbling over all kinds of letters and numbers this week, so John Kalyani, I'm going to need your help going through some news.
It's all downhill from here.
It's downhill from here. Speaking of downhill, I'm going to start off with an article titled, as always, there's everybody loves to riff off the Lord of the Rings. This is one token to rule them all, obtaining global admin in every Entra ID tenant via actor tokens. And this is this was a callback to the CSRB report from Microsoft. I think it was the Exchange compromise back in 2023 that called out a cascade of avoidable failures. And in this case, a researcher who was working on their Black Hat and DEF CON talk was looking at Entra ID. They discovered, oh, look, there is a token, a JWT essentially, that isn't signed. And already that has some implications for tampering. And it just so happens that it's working against a legacy endpoint. That legacy endpoint didn't have all of the access controls that it probably should have. And lo and behold, they were basically able to compromise any tenant they wanted to using in Azure using this actor token. And what's nice about this write-up, it goes through a lot of technical details that I've glossed over very briefly, but it also talks through, is this really bad or not, rather than just saying, oh, hey, look, I could, the sky is falling. They go through some, what I think are very reasonable attack scenarios and ways to get a certain tenant ID, some things like that. So it just overall looks like a really bad vulnerability that you don't want to have, one token that you can request to then be used against any particular tenant of this service in any particular privilege level. So there's some more stuff that I could add to this, but I'm not the one here to do all the talking. John, do you want to jump in on this, or and then we'll give Kalyani.
Where my head, I'm still forming this thought. I did see this morning. And it's interesting. I didn't hear a lot about this last week. This came out, what's the date on it? I don't see one. But it's been out for about a week, I think. It doesn't seem like it's getting the, oh my God, that you'd expect for something of this magnitude. The way I'm thinking about it is it feels like a architectural design failure. From the point of view of someone, one way or another, decided that it was not a bad thing to have the ability to have, in any way, shape, or form, some type of account or token that could access multiple accounts. What? And I'm guessing it's part of that legacy aspect in there, that sort of something got glued together, and here we are. But yeah, that's if you're designing something for a large scale multi-tenant system, I mean, this is a perfect example of where you keep your administrative systems in a complete separate code base, and it's somewhere else, and like it just shouldn't be able to be accessed by a user. So that's sort of the troubling part of this to me. Yeah.
I was thinking that access control has been an OWASP top 10 since 2017, again in 2021, and I'm hoping it makes its way in 2025 too. But I often think about the shared responsibility model when it comes to security, right? And it does not feel like a misconfig on a user's part, but more so like an oopsie by a provider itself. And it just it feels like tenant, like you said, multi-tenant isolation. It's when we, perform all these audits and we're like, yeah, all our tenants are separated. But when your user permissions living in the same database, I think that's gives me an ick. But yeah.
Yeah. And the reason John, pulled out the angle that struck me too when I was looking at this, in the sense of, you've got these actor tokens, they're not signed. Okay, that's an easy, code review type of 101 mistake. But,
or even a pen test. I mean, come on.
Yeah, that's an easy, right? Exactly. That's one of those. Oh, by the way, on the pen test, that's almost your the template that every pen test consultant has. They've got that to add this or not. But some of the other things, especially to your point, Kalyani, there were also no logs around how these are provisioned. And so there's also and there's no alerts that these are provisioned within your own tenant account. You get logs in the attacker's account that, oh, cool, you just requested an actor token to impersonate blah, 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 but poor blah, 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 the technical term, tenant doesn't get any logs there. And so you suddenly have a lot of things that are failing architecture-wise, design-wise, that make one small mistake, that it exacerbates this one small mistake. And that, to me, is definitely the lesson here, not just, oh, you can, change out a net ID value to go impersonate whoever you want. There is, and so we're going to come, I mentioned code review, that I'm teasing that. We're going to build that up for some later articles. I did want to pull in another vulnerability that this is from Curl and libcurl. So Daniel Stenberg, I love following his blog. I try not to pull in a blog post of his every single week, but this time it was bye-bye Kerberos FTP. Now, what was interesting to me about this is they actually got a security report that was legit for once, because poor libcurl folks, they deal with a lot of the LLM bug bounty slop. But this case, there's a classic buffer overflow within the Kerberos FTP code. Stenberg and crew looked into it and they found out, there's actually another bug that means this feature doesn't even work in the first place, and it hasn't worked for well over a year. So rather than just say, oh, we're going to fix this security bug and apply a patch, the decision was, let's just remove the code because no one's noticed, and we actually didn't have any tests that showed us that this feature was failing in the first place. And that to me speaks wonders of a great option for a security response that people don't take often enough, as in just delete the code, get rid of it.
I mean, it's sort of you're removing a feature, and that's always, you got to think hard about that. So it's been broken for what, a year or so. Someone out there is using this in some legacy, some system that's, hopefully it's not Microsoft and Entrada, but someone's using this to, do something. And at some point they're going to want to upgrade for a security fix or something else, and they'll be like, oh shoot, it's not there anymore. So it's curb FTP, so it's probably a very, very small number of folks, but still it's a thing. And that's sort of a big decision. I mean, I think I agree with them, but it's still, it's not a light step to take, is my point.
Yeah, and that's one of the things, even to continue to pick on Microsoft a little bit, one of their challenges, I'll admit, trying to use a more neutral word, is they have preserved, legacy support, that support for some of their code that's 20 years old could still run, but that becomes that trade-off of how do you get off of everything onto NTLM v2, or how do you get on the more, it's come back to bite them and slowed them down or prevented them from getting into stronger architectures across the board or by default. So that's why that particular, because who knows who uses Kerberos FTP these days anyway, although maybe there probably is someone who's stuck on a 10-year-old version of curl, as John points out. Somebody's using it somewhere. But in that article, I did link to an example of an LLM-generated bug bounty report that curl received, which I don't know that there's much to talk about. It's basically just somebody said, hey, here's a proof of concept code about your cookie handling that has a buffer overflow in it. And the curl folks point out, this doesn't even call like curl.h. Like, it's not even calling any curl code. It's literally just a write-up. This is an example of step 1, create a buffer. Step 2, right past the end of the buffer. Step 3, get some money. ... So yeah, ... So I want to jump over to an article from Kalyani highlighted about DeepSeek, but before we do, I don't know if there's anything else you wanted to react to in terms of just LLM generated bug bounty reports or LLM security code reviews for either of you.
I just want to say I feel a lot of sympathy for open source software right now, but like the bug bounty programs are a nightmare, and I do not want to run one for sure. So the whole AI slob, it's an entertaining circus, as long as you're an audience and not a performer. But yeah. Well said, because I enjoyed reading that because I am the audience. I don't have to have my time sunk with that. But I enjoy reading many other things. And here is AI firm DeepSeek has some news. Kalyani, tell us about this article. Sure. So I stumbled across Washington Post news about how China's AI flagship model, DeepSeek, was producing weird results depending on who asked the question. It's basically you given identical English prompts for different coding tasks, but the output depends on who is requesting the code in the situation. And I'm starting to wonder if like AI surfaces like a new geopolitical bias, and like I have like different philosophies on that end. But basically, if the code was said to be from a region that China did not outright support, the quality was like really bad, and it's just creating exploitable software. Now, I think with traditional software, you can find out where the backdoor exists, but like with a complex model like this, it's so hard to tell. Like if the model is trained to behave this way, or there are certain guardrails put in place for it to create content that tries to misalign with like geopolitical views, or it's just I don't know, poison for lower quality data. It's just hard to track the backdoor in this situation. And I think we are entering an era of state-aligned algorithmic sabotages, is how I want to frame it. Like, yeah. Yeah.
Yeah, and here's where it's also, I don't know it's worth being pedantic about saying backdoor, but the reason I'm responding to that is with LLMs, it's very difficult to inspect and understand the model. We don't have some assembly that we could decompile, review, and say, oh, look, here is an if statement, or here is a branch that just does something based on something deterministic. To your point, which supports from this research from CrowdStrike, they at least said something is hinky here. So, and unfortunately, I couldn't find the actual research that CrowdStrike conducted with more specific examples of prompts, more specific examples of the code. But they're asking DeepSeek to create some code for industrial control systems, which already is like, there's probably not much code out there that it was trained on anyway. Mm-hmm. And I think I would be immediately agree that a lot of these models are going to give different results based on build me a bomb, rather than just saying, oh, I am Islamic State, then write some code for me. I'm really curious what these prompts looked like, because it doesn't make sense to whether we call it backdoor or just bias the model. If someone says, I am a terrorist, then write less secure code for them. All they have to say is write me an ICS, write me code for an industrial control system. The mechanisms behind that is a little bit too conspiratorial, except for if the model has been designed to say, don't respond to Islamic State, Falun Gong, or some entity that we disapprove, then the model is going to struggle, or it's going to attempt to not provide as much content, whether it's writing a few paragraphs of text, whether it's providing history, or whether it's providing code. So that's where I'm just curious about how much of this is a prompt in the model that says, introduce vulnerabilities, where we saw explicitly with BadSeek that we covered several months ago, or it's just don't provide support to this topic. And that support just becomes a struggle to not string a bunch of tokens together. So that's my hopefully non-chaotic take on the words that I'm trying to string together in a response to this. John, help me out here.
I'm just sort of thinking through, like, so first a nitpick on Kalyani, it's state-aligned prompts, not state-aligned algorithms, which is sort of interesting, right? But so what is that? How are they prompting it? I'm sort of going down the same path you are, Mike, of like, were they just saying like, hey, don't write, if we know who it's person X, just give them bad code, or is it actually saying write something with vulnerabilities in it with the intention to go and later compromise it? I'm not sure if there's really any big difference there, the way you're doing something intentional. Yeah, this comes back to it seems like there's an interest out there with people, a growing interest around open models, not just open weights, but open models. But that's like, when you're dealing with these systems that are like, 237 billion parameters, how do you audit that? It's just, and in this case, do you need to audit the model? Because it sounds like, at least from my read, it is on they're prompting it.
Yeah.
So, okay, do you somehow do full disclosure on those prompts?
Yeah.
We've seen people try to reverse them out of like Grok and things like that, probably most of the systems, but I'm not sure how you really provide transparency on this.
I think there's just like one single thought I had is like, what is our AppSec playbook here? Like, sure, we can threat model the code that we generate, but how would you threat model the whole AI model that you're querying at this instance? I think it's a little more complex, and we're still in the nascent phases of threat modeling the whole AI model, but yeah.
Yeah, and I think that's a great thing to focus on, because these LLMs are such black boxes. And to your point, Kalyani, there is even Grok has been demonstrated to be a non-state actor that has been manipulated to have very unfortunate biases. I say as a very simple gloss over of Mecha Hitler, for example. Like, it's just a long sigh for the types of ways these can be manipulated. But on the code review part of me is just how much does it matter who is writing the code or how the code was produced? And what does the code contain? Does the code contain vulnerabilities? Does the code contain something that is adversarial in the sense of it has a backdoor that is attempting to be obfuscated or obscure in some way to bypass a human looking at it? And that's definitely a AppSec responsibility, or an AppSec falls under that AppSec umbrella, Kalyani.
It does.
So
But I
let's
will, yeah, it's good.
let's talk about a bit more of that AI as a code assistant, or the code review assistant. I pulled out an article from let's see, who is this? OpenSSF. It is the security focused guide for AI code assistant instructions. And what's interesting is, as Kalyani was kind of noting about the Washington Post article, the CrowdStrike research is kind of implying that there's a prompt, or there's something in DeepSeek that says, if this person is someone we don't like and they're trying to write an industrial control system, make them 20.3% less secure. The prompt might be less specific than that, but who knows? I look at this work from the OpenSSF, and what's interesting to me is that it seems to be boiling down to the joke that we often have, John, of how to refine the prompt for the code to say, oh, you're writing this in Rust, make sure to use this Rust feature. You're writing in C++, make sure to use this C++ feature. Or you're doing authentication, make sure to sign your JOT. Things like this, which boil down to variations on the comma, but make it secure. Like, it's really just a long article that's trying to say, how do we prompt AI assistants to make secure code? And I don't know, I appreciate the work. I appreciate the write-up for this, but it just feels to me like, why? So that's what I'm trying to grasp here, just in the sense of, why do we want to try to make the AI, the prompts, we spend all this time on prompts that might or might not work? Basically, I'm touching on the non-deterministic part, versus just having better code, having better linters, having better compilers. I don't know.
Exactly. Yeah. I think this is a case where, like, I think you could maybe add, I think it really is just, from my point of view, add one or two lines about, what make it secure into your base prompt, but your memory, whatever, pick your the phrase for whatever system you're using. But it feels more like you want to have another party. Either it could be another AI, or it could be another just standard, run-of-the-mill, quote-unquote, legacy tool that goes back through and reviews it. We've got those. We know they work. And I'm sure they'd catch the mistakes quite easily, at least most cases. And that at least seems to... You're looking for a balance, I think, is where I'm stumbling through.
I think the balance is harder to strike when it's like a smaller team. Like, say, it's like, think about the security divide here. And what I mean here is, maybe it's like a 5-person startup, or like a volunteer run open source project. And all of them might not have like these mandatory, rigorous checks throughout, like the legacy tools that we're talking about. And instead, we're just relying more on an AI assistant rather than on like a proper SAST or DAST tool. Which means, like, even if we might be missing like defaults in place, how much more is the AI assistant going to help here? It's almost like it's going to widen the gap anyway, for companies who have the guardrails versus who don't, which is what I mean by the security divide in the first place. It's like bigger companies might have the tools to like ship secure code, but the smaller ones might just over rely and ship vulnerable builds, is where I'm coming from right now.
But I think, does using the LLM generated code change anything there? Because you're still, even if it's human doing, you're still going to have to. And I'm not justifying. Is there a difference?
I think it's just maybe missing the checks that we usually have in like a traditional pipeline because we're over relying on an LLM in this case.
Yeah, and I think to me it sounds like, especially if I can imagine there's an appeal to smaller teams that you're noting, Kalyani, in the sense of there's only a few of us. What if we had an LLM help us write the code? And OpenSSF is here trying to say, if you're doing that, here's how to write some, quote, clear, careful, and security-focused instructions to greatly increase the chance that this coding assistant produces code that's correct and secure. What that really sounds like is you're writing a cybersecurity awareness PowerPoint for your AI. And I think what you were touching on, Kalyani, is
I'd love to see that.
why are we investing this time in the LLM rather than just the people write the code and maybe have the LLM supplement the SAST or supplement the DAST or what, we can rattle off a whole bunch of acronyms. But if we have a prompt that says, for Rust, I'm just picking on something at random, in Rust code, avoid using unsafe blocks unless absolutely necessary. That feels like just have the LLM look for that and make a code review comment. It looks like you're using unsafe. Is this absolutely necessary? Which I would also argue that just sounds like you're running grep for the use of unsafe, and just have a prompt to the developer that says, click here that says this was absolutely necessary code. Because I love I love having a little checkbox that says, yeah, it passed all the tests, it passed the linter, and the checkbox for absolutely necessary. So that's what I'm going to start lobbying for in my release checklist these days.
I wonder if anyone's tried creating a prompt yet that says, listen to all episodes of Application Security Weekly, and then write the following code.
If it produces Perl, I'll feel like I have failed. But what's funny here is to go back to there's an angle that Kalyani brought up in the sense of creating the guardrails and the size of teams, because many smaller organizations don't have a dedicated AppSec team. They might even have to go through the dreaded, we need a sound effect for this, the shift left, meaning like the developer suddenly gets all the responsibilities of AppSec, and which basically just means write secure code. And I guess that here is maybe that divide, or is also how much do we rely, or would you rely on the LLM to write code versus to provide code review? Do you have any preferences or ways that you would encourage or argue for a small team trying to answer that question?
I want to say both, but I also want to say that there would be preference to rely on LLM to maybe write better code QL queries than someone would originally write. I think it's like John said, that there's a balanced approach that we're looking for here. I think it's very hard at this point to be like, don't use an LLM to generate code. So it's gonna happen.
That battle is lost. Yeah.
Yeah. It's just about how do we use it in a way that we don't shoot ourselves in the foot. Yeah.
Yeah. And I think, and part of it is the reason I pulled out that quote about clear, concise instructions. That is, how do you talk to a human? We want them to explain a strong design, explain an architecture, and as a bit of a callback to threat models, explain what threats this architecture is considering or not considering. And did your design goals meet that threat? How much do they mitigate that threat or not? And the reason I'm going on a bit of a tangent there is to pull in a segue to some very clear, not necessarily concise, but well-structured documentation from Apple Security Research. And this is about MIE, Memory Integrity Enforcement, a complete vision for memory safety in Apple devices. And there's a couple things that I wanted to talk about here. This is a combination now of hardware and software. So we're getting out of the LLM world and just into that chocolate and peanut butter, two great tastes. It tastes great together. One of the things they point out early in this article is that they were a pioneer in using pointer authentication codes and using memory tagging, which is a 6-year-old technology. But when memory tagging first came out, they reviewed and they said, oh, it can cause a crash that's synchronous or asynchronous, meaning you can opt in whether you want memory tagging to actually block the exploit, which is what's implied there. And there were a couple of other aspects of memory tagging, which is a security design, that just weren't meeting the threats they wanted to meet. And that's why they came through with enhance. They threw an E at the front. So they actually did the Blade Runner enhance, and that worked. And then they got into MIE. But before we get into a bunch of that, I don't want to be the only one talking about this. I'm going to John first every time. Kalyani, not to put you immediately on the spot because it was a long article to get through. Is there something that really appealed to you from this particular article about, whether it's software, hardware, or something else about their approach to threat modeling or secure design?
I want to say that this is like a very ambitious effort towards memory safety and obviously secure design. And I feel like other hardware companies like Android should level up is the blunt way to put this time.
Yes. And the article it's similarly blunt, but it doesn't throw shade. It shows where Android was pioneering some additional things too, but it also does give a little bit of contrast where it's saying that, the memory tagging on Android is, quote, limited by a lack of deep integration in the operating system. Whereas Apple is saying our iOS and our new iPhone 17 has a really tight collaboration here. And they have some wonderful and simple illustrations that say memory tagging helps with this broad course problem of memory safety issues. The enhanced memory tagging makes it on by default, so it's for everyone. It makes it only synchronous, meaning if there's ever a problem, it automatically crashes the program rather than potentially enabling the exploit to continue. And then it says MIE adds that additional bit of granularity. So it's a nice walkthrough of consideration of performance. That's what developers care about. It's what end users, honestly, are going to care about too. And it points out that MIE is not the one-size-fits-all that fixes every single type of vulnerability out there. It shows how each of these steps try to break those exploit chains and how they explain how their own offensive research team was saying, this particular exploit doesn't work now, this doesn't work now, even if vulnerabilities might still exist. And that's what to me really appealed about the way this article was presented and considered and talked through its particular threat models without using, it didn't have to use Stride, it didn't have to use Dread, but it walked through a very nice threat model. So John, you're on the spot now. What do you think about what Kalyani and I have been talking about?
I'm really curious about this. I'm still trying to take in the paper. I'm going to have to go read this in detail later. I'm Apple fanboy from the security and hardware point of view. What caught my interest, what I want to sort of dig into later is, and you guys might know, this work that ARM did on the memory tagging. I'm curious if that is used in, I've got selfish reasons here, I'll let people guess, but I'm curious if that's being used in the ARM server chips. And how much of that is it being used? Are compilers taking advantage of it? Does it need to be coded? Is the applications? I'm just thinking from a security point of view, what the ramifications are there from a server point. So that's sort of where my head's at the moment.
Yeah, and I wanted to grab some more, what is the Linux kernel doing to take advantage of these directly to your point, as well as we're talking about ARM, but there's also RISC-V out there that is very open source and an open project to build similar chips. And it would be really interesting just to see how much of that direction of these chips are providing these primitives that software then can take advantage of. So this to me, if we're, as John said, training that LLM on go listen to all the episodes of Application Security Weekly and create some code, hopefully they'll also come up with, we're not overly pessimistic. Here's a chance to be optimistic of the future is the point I'm trying to make. So I liked this. Tired of the endless cycle of cloud vulnerabilities? Avoid over 95% of CVEs with minimal container images from Minimus. No bloated base layers, no unnecessary packages, just what your app needs to run. Drop Minimus images into existing deployments to dramatically reduce your attack surface and remediation work. Maximum security, minimum effort. That's Minimus. Visit securityweekly.com/minimus to learn more.
So I did some quick Googling while we're talking. Graviton does have memory tagging support from the ARM AArch64 8.0. So it's in there. And yeah, then the next question comes down to like, okay, does Linux handle it? I don't know. This things. I think we could sort of deep dive on this one. It's interesting to me.
Yeah, and listeners, if you have someone who's the ARM expert, RISC-V, or Android, and want to give their perspective on what they've been doing to tie that software and code security together, let us know, because we'd love to have them on as a guest and have a more conversation about that. And I'm going to use this too. There's another point that this article calls out about Spectre v1 that is something that was highlighted as all of the Spectre countermeasures really difficult to counter without introducing 10% or greater type of CPU overhead. And that's what, once again, developers want to avoid. They reference one particular Spectre v1 type of attack and I think I linked to a type-based data isolation that's an IEEE paper. But the reason I was noting that is that we've got another article from Kalyani that's also talking about, similar to Spectre, another hardware level type of vulnerability. Tell us about that. Take us into another row in our list of news articles here, Kalyani.
Let's go. So I'm a newbie in the whole hardware world when I'm trying to understand different kinds of security attacks in there. And so for our listeners who are just like me, let me explain what rowhammer exactly is. So basically, rowhammer happens when you're rapidly hammering certain memory cells so that the bits in the neighboring cells would flip. And what that means is it would give an attacker access to maybe critical data that they're not supposed to have in the first place. And there were protections in place earlier, which would not let this happen. But it turns out with the new research that Google and I forget one more university carried out, which is called Phoenix. And what Phoenix does is that it shows is that like even the newer hardware on which most of our models even run now, they're not safe either. Where they were able to exploit it in such a way that they could take full control, were able to access memory that was off limits. They were able to even escalate to root privileges about 1/3 of the time. And so the basic mitigation that you put in place for things like this is maybe like tripling your memory refresh rate. But that's not going to be cheap. It's obviously going to be more expensive, and also it's going to be an uptick in performance problems. And I don't know, rolling out hardware just takes much longer than rolling out updates to software. But for me, this was a new introduction to like the physics layer of security.
And it's a great tie-in with that Apple article because they also point out with memory tagging, for example, or even in the Linux kernel, the ASLR relies on secrets. And those secrets you need to keep away from an attacker because otherwise they could trivially bypass memory tagging, for example. And so what Apple did in their hardware is say, here are some paths that we don't want to have any speculation for, or we want to be very careful that the hardware can't provide a leak or a side channel of some sort, a la Rowhammer. Rowhammer is manifesting in a different way, but it's a great example of there's research out there of how do we get the CPU or the memory in this case to give us some secrets, something useful. And even if it only works 1/3 of the time, if you're targeting, a server farm of 100,000, 200,000, 500,000 servers, the odds are easily within your favor. And I don't know, John, is there anything else? You're a resident hardware geek. I think we can even in the background, there's some solder on the table behind you for our viewers can point out. So you got to add something here.
Where my head's sort of at is I'm going actually in the opposite direction on this one. And the question I'm asking is myself, well, I guess out loud now, is how is it a good thing to be this closely tied to the hardware? And I'm thinking there around like the last article we were talking about as well. Is this is like frequently, if you're in a position like Apple where you own the hardware and the software and you're able to have those two things tied together really closely, that's great. But for a lot of us that are writing maybe just a general program and you're not really thinking too much about the hardware that you're running on, or maybe you are, say you are writing for that ARM CPU and it has memory tagging and like that's going to be a part of your defense strategy. A year or two down the road, maybe ARM chips aren't available. There's another COVID or something happens and you can't just get those chips. So you have to run on Intel or AMD. It's how much of your security are you losing if you go down that path. So I think that's it's not a deal breaker by any means, but it's one of those thoughts you have to have when you sort of think through how are you using these things and what's your dependency on there? Do you need to be flexible? Is there a point in the future where maybe that doesn't exist? Then what happens to your app? So that's at least something to think about.
That's a great, because it's a callback in a way to what Kalyani said about the size of organizations, or who are you developing? Because I think we can list on less than one hand, if that phrase even makes sense, the number of companies out there, building mobile operating systems or building, using C, C++ to write code, and who care about that low-level hardware. And that the opposite end of that spectrum is an article that I pulled out about WASM 3.0, which is on purpose independent of hardware. Before we get into that, I don't want to leave, well, it's not hardware space, but the secure coding space, because John, you had an article about C++, which, don't worry, listeners, don't fall asleep quite yet. We're not going to go into the template programming and try to analyze a template compiler error because they're way too long. There's something else around here that's useful.
Yeah, so I brought this up sort of, it's not quite the 6 months later thing that we talk about or joke about, but we have in the past talked about the Safe C++ proposal, which came out when the folks over in the C++ camps were going, oh, you don't need Rust, C can be just as good. And it turns out that at least this one proposal has, I don't want to say it's been deprioritized, but people have decided that's not the path they want to take. So the author of this blog post looked around found some talk about this on Reddit, and to quote from that, the Safety and Security Working Group voted to prioritize profiles over safe C++, asking the profile people for an update. So I went looking around. He has a few links in there, and there's a paper, sort of intro paper from Barn Strostrup. I think I got it right. And basically, to quote his intro, a profile is a set of guarantees such as type safety, absence of resource leaks, and range errors. So it's sort of an optional thing, but they're trying to basically allow someone either on a whole source file or on parts of it to say, we want this to be a little more, I guess, the opposite of unsafe in Rust. I'm not sold on it yet. I haven't found any code sample. Oh, no, I did. So yeah, it's basically done through like tags in the code. It's there. I think it's something we'll have to play with or watch and see how it catches on, if it catches on. But they're still trying, but they're just trying it with quote unquote profiles, not safe C++.
Yeah, and it's interesting too to read an article like that and see how much of it is a little bit of language wars, because there's clearly they're looking at Rust's safety model quite explicitly, and there are disagreements, or what's the opposite of desire? A non-desire to follow the Rust model of safety and have C++ go into this tagging, if you will, and say, hey, I do want my profile, when you build my code, build the code in a way that introduces a bit of overhead, but has these extra guarantees about pointer use or undefined behaviors that are common artifacts that lead to security problems. And here I'm going to pull in. I want to pull in one more. Oh, go ahead.
One last thought on this. I'm looking for which one of these links I saw it in, but they had one of the authors around here had a really interesting point. in that what they were trying to do is the way C++ and C has been created as a language, it is very easy to do the wrong thing. And what they were trying to do is to provide, I'll say, a framework to make that less. But I thought there was something about, instead of saying it's an unsafe language or pointer bad or all these different things, the way they sort of had set it up, I really sort of liked that the wording of like, hey, this is a powerful language. It's powerful enough that it's easy to do the wrong thing and get yourself in trouble. And I think what they're saying is comparing that to maybe Rust or some of the other ones where you're a little more straitjacketed and you sort of can't do as much, but it's an interesting comparison.
And even in to come back to, as I keep doing, the Apple article, they didn't say we're rewriting everything into Rust. They're using C and C++ to take advantage of this hardware primitives that are being created. But it does mention that they have some targeted component rewrites, their words, into Swift, into basically memory safety. And that's starting to, I do want to do one more discussion about the code review and talking about code. But before we completely make that segue, Kalyani, I think you were about to say something.
Yeah, as a C++ noob, but I had a thought in my head, which makes me feel like, aren't we like relying on developers? Like we're putting this burden of targeting the right profile on a developer, and they have to go to the homework on what checks will be enforced and what does unsafe code, look like in this. And I don't know, the security revolutionary in me feels like, why does a developer have to go through so much? Yeah, that's just a plain simple thought I had.
Well, and you definitely, I'll pull in. Let's start the language battles. I already picked on Perl. PHP, for example, notoriously had some settings like, what was it? PHP unsafe, PHP safe mode that was always misunderstood, but you could have like a server-side configuration setting that would make your code behave in a different manner. And that's the thing that you don't want to surprise your developers about. If they have, here's the code that I created, here's how I expect it to work. But if you have something that is a configuration setting, either that the compiler makes it different or the runtime environment makes it behave differently, that's unfortunate and unexpected, because now you have to figure out, how do I either just not run in that type of situation or accommodate that situation? And that touches maybe a little bit on WASM that I want to pull in just for personal reasons. But there's also code review. And here, John, we should probably end with it, since we've been talking about code quite a bit this segment. You had an article, a little bit old, admittedly, but I think it's still pretty universal. Code review can be better. How can we make it be better, or just and make it not just be bananas, as it always is?
Obviously. Come on,
code review is bananas.
Solves everything. We found this one probably pretty soon after it came out in August, and it's just again the right time to both read and study and think about it, and then bring it out to our listeners. So this is written by a guy who created a tool called Git-Review, and I'll set up his mindset, which is. I'll start with his saying that, hey, I don't like using GitHub for doing code review. And the thought process he has around that is sort of fewfold, but it's like, if I do the code review on my local machine, it's my local machine, it's faster, I've got more memory, I can like run the code, I can run the tests, I can look at what they did, I can start with the base and then apply like the patch on there and see what's actually changed and go through file by file. And what he does is he puts the files into, I can't remember the name, but like the Git staging area. So he can sort of use that as his to-do, that he's looked at that file. Now let's go to the next one. He's makes some comments about not wanting to be locked into a vendor like GitHub, which I think that's a little weak, I think, that argument. But yeah, that's where he's coming from on this, or at least initially. There's one sort of point here I'm going to go to, which I think is the interesting part. I don't know. VS Code has plenty of code review tools built into it, so you can pull down that GitHub review. You can run it and do the things. So I think part of it is it might just be his style of doing things, or maybe he's not using VS Code. But where things got really interesting for me is when he brings the full idea in that, hey, the code review process isn't just improving code. That should be part of the history of that Git project from the point of view of if I'm making suggestions to you, Kalyani, about, hey, maybe this line isn't written right, or maybe you forgot to terminate a string or what have you. If we just look at common nowadays in GitHub or other systems, you just see a new, well, if we're not flattening the merge, you'll see another commit with some changes in there, but you don't really have a solid reason why. You can guess, or your commit message might say, hey, I'm changing this after John said something. And as I said, if you flatten out that merge, it's all gone. So you lose the history of the why behind what's going on there. So what he was trying to do was to actually put the comments as comments in the code and have that as a new commit on top of that branch. And then when you make the changes in merge, that becomes part of the overall thing. So I like the idea of that. But as he sort of found as he wrote this tool and started playing with it, on a active project or a project where there's multiple people making those commits in there, you might run into, as I call it, merge hell, where you'll have, I can't remember the actual technical phrase for it, but you'll run into, your merges might get screwed up and things get ugly. And particularly since you were making comments right around that area where the code's being changed, and that's where Git's going to have a hard time actually figuring out the merge. So yeah, it's an interesting idea, but it sounds like they're working on maybe adding some capabilities into Git with a change ID, which might sort of help with this. So the change ID on top of like the Git commit ID. So they might be playing with some ideas to make this easier. But right now it's sort of a thought experiment, I think. But I'm curious what your guys' thoughts are on that experiment.
Yeah, I'm especially curious too, Kalyani, because you talked about, especially, making sure we focus on, there are small teams out there, and they're not teams that are 5,000, 10,000 developers working on a massive monorepo. Code review can be pretty important, can be consequential, can also be more than just, oh, you forgot the semicolon at the end, or this color should be fuchsia instead of something else. What are the ways that you've seen be effective code reviews, whether it's a security dimension or not? Or what do you try to encourage developers to do when they're looking at code reviews?
I think I made this comment earlier on where I feel like code review, the longer the code review gets, it makes me feel like paperwork. Which gets taxing. The more number of pages, I know my answers get worse as I'm at the doctor's office filling all the paperwork. I forgot my family history. I'm sorry. And I'm pretty sure that's how a developer feels too, because it's like too much of a context. And it's just hard to review. So I think just a good hygiene is to have like bite-sized reviews and easier for with LLMs in picture. We keep talking about LLMs. I'm sorry, it's hard now to talk about LLMs.
Totally, yes.
They produce so much unnecessary code, and they make you download so many unnecessary extensions. It's just like inviting problems when you don't have one. And it's harder to make code review effective if it's going to be 50,000 lines of code that one has to review.
Yeah, and I think part of me, I was trying to understand what the real gist of this article was getting at, or what the problem statement was for this article. And to me, it's less about, it seemed to be more about, we had this discussion about a code review, and we don't want to lose the context, or we don't want to forget about why we made these decisions, because sometimes those code review comments will be, hey, this is too much paperwork for me. Can you split this into 2 different PRs or 3 different PRs, to Kalyani's point about just what can our mental, what can our human brains keep evaluate, which LLMs have their own context windows as well. But here is more about the idea of there's a concept called Chesterton's fence. Like we made this design decision, or we made this architectural decision, and if nobody can remember why, and it gets changed, you push that to prod, and suddenly the database gets erased, something terrible happens. You're like, oh, that's why we had that particular code path in there. And we didn't put a comment in the code to say, please don't remove this. It was part of the discussion in the commit. And that's what it sounds like this article is really trying to capture is, what were those meta discussions about why we made these choices about this particular merge? And let's not forget that, which honestly sounds like it would be useful as context for an LLM if you're trying to get an LLM to understand, to be an assistant in reviewers. It seems harder to propose that as additional homework for humans, but it does on a regular basis for code reviews. But it does sound like it would become immensely helpful once you get into one of those sevs or you're trying to figure out, the alarms are going off. We had a bug. How do we get into why did this bug, why did this code get introduced, or what happened here, or what went wrong? That does feel like suddenly a very good artifact, that's my word of the day, to be able to reference to.
I think my joke of the week is going to be that I filled up my context window. But I think, so it's in this interesting conversation. It doesn't, if a PR or a CR is like too big, that's a problem, right? That's sort of a completely different issue. You're just basically DOSing the people who should be reviewing it.
Right.
At the same time, it shouldn't be extra work, I don't think, to do this. It's instead of making those comments in a GitHub code review, you're making them in the code itself. So it'd be interesting. What might be interesting to see is over time, does this make the code really noisy? Does it become more readable or less? Do you have like a concept of you go through once a year and you clean out some of the old CRs or like CR comments, or how do you? It'd be interesting to think about what does this look like over a longer term project. The LLM thing is interesting to me from the point of view. One of the things I've been tinkering with for the last few months is how do I think I might have talked about this on air before. If I'm vibe coding or spec coding is easy because it's a document and that's going to become part of the Git repo. But if I'm just saying like, hey, make the change in this thing and a bunch of code changes, again, like you don't know why. Someone I know at work is actually now putting his prompts in as part of the Git commit message, which I think is really ingenious. Because part of what I want to do there is not just show why I did it, but also if people are looking in the future, they can learn from this as an open source project or inside a company or whatever. They can go, oh, that's how we got it to do this type of thing. It's to me, I'm a fairly strong believer in the idea of like, it's what's the intention behind this or what's the history behind this. So that's where this sort of really tickled me.
Yeah. And I can imagine, in terms of the code being noisy, I can imagine easily like a VS Code, have an IDE plugin that elides this conversation. So you're just looking at the code or brings it back in when you want to see that context. Those feel like they're easy solutions there. Kalyani, it was wonderful to have you here, and I want to throw over to you for the last thoughts of this episode, because we are running out of our own time context window, and we have to wrap up, but we haven't seen you in a while. What are some final thoughts you want to share with our audience this week?
Final thoughts is I am curious to see how we're going to secure the vibe in the next couple of months.
Secure the vibe. That sounds, you got to say that with definitely much more of a SoCal accent. I just love that. Thank you, Kalyani. Thank you, John, for both making me laugh this week, and hopefully everyone else too. Thank everyone else for joining us. Please do remember to subscribe, check out the show notes, share us on the socials. And speaking of the future, check out Abandoned Horizon by Light Racer. We'll see you next time on Application Security Weekly.